Today on Real Garage, we're getting sprung, except with a twist. I'm TIG welding the rear end coilover mounts, but I'm doing it in style with a water-cooled Multimatic 220 conversion project. This is going to be a pretty cool project. I know quite a few people who are looking for a way to put a water cooler on a Multimatic 220 because they want to use different torch options that are only offered in a water-cooled design, or they're tired of their hands getting hot using an air-cooled torch during longer TIG welds. So the problem is we need to adapt the 25mm air-cooled DINS connector to a water-cooled torch using an air to water-cooled adapter. Unfortunately, the adapter has an end that's 50mm, so it's too big. My first design required a good bit of machine work on the lathe, tap, and die, but I decided on a way that anyone could make this work. You already have a TIG welder. Why not just take the 50mm end and cut it off and weld the 25mm in its place? The part number for the air to water cooled adapter is a 195380. And the part number for the air cooled 25mm connector is a 273483. After stripping the 50mm adapter clean, cut the end off. Make sure it's ground or filed flat. Okay, it's time to cut the 25mm adapter off. That's going to be no less than 19/32 of an inch from the end, or an 1/8 inch from the shoulder. This measurement is critical because there's a little countersink on the plastic bezel. We want the adapter to twist lock home brass to brass, not letting the plastic bezel be your stopper. Also, we don't want it too long, so there's excess brass showing. To be on the safe side, I'm cutting mine off a strong 5/8 of an inch from the end, and then fine-tuning it flat to the measurement I need. I'm using the 1/8 inch gas holes to align the parts with a piece of 1/8 inch filler metal. Make sure there's no cutting or grinding debris in the holes, and leave enough through the top to be able to remove it after tacking in place. I used a 1/4 inch nut on top for a clamp spacer. And make sure to clock the twist lock pin towards the water outlet port. So let's talk a little bit about welding brass. It's not really fun. Actually, it kind of sucks. So let's manage some expectations. First, I'm using 1/16 silicon bronze filler metal. Silicon bronze melts about 150 degrees higher than the brass. It's a lot tougher than using silicon bronze on steel or other higher melting point metals because the brass actually melts, causing some popping and gassing from the zinc, which is why I have a small fan set up behind me for some positive ventilation. Both brass and silicon bronze are copper alloys. The C360 grade of brass is the most common for machining applications and contains about 60 to 65% copper. The silicon bronze has over 90% copper. So you might want to take your drop-off pieces you cut off and do some test runs to get familiar with how it welds. And keep a stainless steel brush handy so you can clean your parts in between welds. Warning: read and follow all labels and your owner's manuals. Okay, like I said, I'm just tacking this first. I got my Multimatic 220 set for DC 200 amps, which I'm regulating with the wireless foot control. And I actually have my gas turned up to 22 cubic feet per hour because I do have that fan running behind me. You can see it kind of was a little poppy and then it, cleared up a little bit, but that's what you can expect. After you wire brush, you can kind of see it does turn out a little bit nicer. So now I can take it apart. And we are tacked. There. Not horrible. You can live with that. Might have to take a file and just clean up this mating surface, but other than that, I think we're good. All right, now that we've finished our custom water-cooled adapter, we can talk about our other water-cooled accessories, starting with the TIG Torch. I chose the Miller WP-225-25-R Modular TIG Torch. It has interchangeable heads, so you can make dozens of different configurations. You can get the heads in a big kit, or you can get them individually. Kind of like the kit that I put on my air-cooled torch back on Season 2, Episode 1, if you want to review that. You're also going to need one of these unions, so you can connect your male gas hose from your adapter to the male gas hose on the TIG Torch. My cable cover is a part number WC-3-22, and the water cooler I chose is the Coolmate 1.3, which I scored this one used. It came with one of these cables that you plug into the back of the machine, but you need to find one with a 120 volt plug on it, which is no problem because the other side that plugs into the cooler is the same as the old computer monitors and some power supplies. So finding a cord with the 120 volt plug is no problem. And actually, I think if you buy the cooler new, it comes with both cords. Now the fun part. The cart that the Multimatic is on is barely big enough to fit the Coolmate 1.3. And that's if you stuff it in from the backside, which means I have to strip the cart and take the bottle rack off. That's what we're doing next. Just fits. Okay, I can see an issue already. My filler neck isn't pulled forward as far as I thought it was going to be. That's the problem with on-the-fly engineering. Sometimes you run into these things. I can still get the cap on and off, no problem, but I'm going to have to punch a hole in my top tray so I can fill up the tank. The Multimatic 220 is 21 inches long. That puts me right about here. Still plenty enough room to punch a 1-inch hole. I actually got room for an 1.5 inch hole, which is better to get my funnel into. That's better. Okay, for all you water-cooled beginners, we're actually not using regular water. Regular water has minerals in it, which minerals make it conductive. When you're TIG welding, you need non-conductive coolant. This coolant I'm using here is from Miller. It's part number 043810. If you're going to use water, make sure it's distilled water or deionized water. Unfortunately, then you have more of an evaporation rate. Getting the special coolant that's non-conductive gives you the best of both worlds. Gives you antifreeze protection and low conductivity. All right, let's put our adapter on. Actually, before I take the handle off, I have the locking screw on the adapter piece that we made. Notice there is a little bit of brass showing on the end. It's not excessive, but there is some variances on this handle. You can see it does move a little bit. So I think what I'm gonna do is I'm gonna take this R21 size O-ring, which if you're into the AS568 standard, I think it's number 216. And I'm gonna put that right on the end before I put it inside the machine. So it does take up any additional space there. And that's not from the welding we did. That is actually from the original piece. So there was some brass already showing. So take this handle back off. I'm gonna do the power cable first. Anything with water, the water fittings are left-hand thread, whereas the regular gas fittings are right-hand thread. And it's easy to identify that because the fittings have a little notch that's machined into it, so you can definitely tell the difference between the two. Handle back on. I like to clock my hoses so that they're facing down after you tighten them. These take a 7/16 wrench. Just like that. All right, and the gas hose. The blue hose is the cold water out from the cooler that goes directly to the torch head. The red lead coming back the power cable is the hot water that will eventually go back into the cooler. It's all color coded, so again, your red water lead is going to go to the marked red fitting on the cooler, and the blue one goes to the blue. Again, remember it's water, so they are left-hand thread. Those are 11/16 size wrench. All right, now you can decide how you want to manage your cables. I like to loop them up a little bit and then attach them to the top here or the side of your cart. Whatever you decide to do, if you're using zip ties, don't zip tie them tight because you're going to restrict the water flow and that's going to burn up a torch. So this is how I did mine. Notice I don't have any tight cable ties. It's all loose. I did make one extra loop on the gas hose and did zip tie tight the connector here. All right, here's the finished product. With all the cables and everything attached. Okay kids, I've let this thing run for over an hour to check for leaks. I don't see any, so it's time to give this thing a test run on some aluminum. I'm using aluminum because if there's any gas issues at all, it'll show up on aluminum before it does on most metals. And I'm using 1/4 inch stuff so I can really put the water-cooled torch to the test. Runs great. One more thing. If you really want to make this setup super sexy, you'll build one of these dual voltage switch boxes to turn both the welder and the water cooler on at the same time without having to drag 2 extension cords around. One extension cord goes in on the bottom up to a heavy duty 40 amp double pole single throw switch, which turns on the 240 volt for the welder and a 10 amp circuit breaker 120 volt duplex receptacle for the cooler. Now I can finish welding my rear end coilover mounts. On this car, I'm mounting my coilover shocks 90 degrees to the chassis. On some cars I build, I will add a couple mounting options at an inward angle. This does change the spring rate a little bit. I'm just using this small angle finder to make my final adjustments. Then tack the upper mount and drop the rear end down to give me some room. Using this water-cooled modular torch is going to make welding this a lot easier. I'm starting with a straight pencil style head to weld one side, then changing it to a 70-degree head with a flat back cap to weld up inside between the mount and the inside frame rail. Trying to get a MIG gun up there would be pretty difficult. All right, that's a wrap for this episode of Real Garage. And I can say I really dig The water-cooled Multimatic 220.